digital to analog converter or D by A converter. So this is the basic block diagram of a system where D to A converter as well as A to D converter is employed. Here we have a plant. From the plant, through a sensor or transducer, we obtain the analog signal, and this analog signal is fed to a anti-aliasing filter whose output is band limited analog signal. This band limited analog signal goes through a sample and hold circuit to produce discrete analog signal. This discrete analog signal is fed to analog to digital converter whose output is discrete signal. This discrete digital signal will be processed by a digital signal processor or a computer. So the output of the processor is digital binary signal, which is given to a D to A converter. D to A converter means digital to analog converter. So the output of this is a staircase signal. It's an analog signal, but it is a staircase signal. By passing the signal through a smoothing filter, the controlling analog signal will be produced, and this goes into the plant. ADC, analog to digital converter, should be preceded by a sample and hold circuit. The ADC output is a sequence in binary digit. D by A converter or digital to analog converter is to convert a digital signal into analog signal. Output of a D by A converter is commonly a staircase. Staircase like digital output is passed through a smoothing filter to reduce the effect of quantization noise. So this is the schematic of a digital to analog converter. So the input is binary word. So D1 is the MSB, it is most significant bit. DN is the LSB, least significant bit. So this is DAC, digital to analog converter. This is the output signal, output voltage and output current, and VR is going to be the reference signal. The input is an n-bit binary word D, and is combined with the reference voltage VR to give an analog output signal. The output of a digital to analog converter can be either a voltage or current. For a voltage output DAC, the D by A converter is mathematically described as V0 equal to KVFS into D1 to power minus 1 plus D2 to power minus 2 plus etc. plus Dn to power minus n, where V0 is the output voltage, VFS full scale output voltage, K is the scaling factor usually adjusted to unity, D1, D2 up to Dn, n-bit binary fractional word with a decimal point located at the left. D1 is the most significant bit, MSB, with a weight of VFS divided by 2. Dn is the least significant bit, LSB, with a weight of Vs by 2 power n. Or two or ladder type. This is one of the most important type of analog to digital to analog converter. So here we shall see a 3-bit DAC, digital to analog converter. So this is the circuit diagram of R to 2R ladder type 3-bit digital to analog converter. Switch position D1, D2, D3 corresponds to the binary word 100. So this is 1 because it is connected to this. This is grounded, so 0, 0. So the binary word is 100. The circuit can be simplified to the equivalent form. So here you can see, you can further simplify this. This 2R and 2R parallel, so the equivalent will be R. So that R and this R series 2R. Now 2R, 2R in parallel, you will be getting R, and this R and this R are series, you will be getting 2R. So your circuit simplifies to 2R, here 2R, R. So this combination is 2 by 3 R. Here the voltage is minus VR. Now at point C, we will calculate the voltage. So this resistance, right, divided by sum of the resistors, multiply the input. So we are applying the voltage divider rule. So we will be getting voltage at node C can be calculated as minus VR into 2 by 3 R divided by 2R plus 2 by 3 R. If you simplify this, it simplifies to minus VR divided by 4. The output voltage is V0 equal to minus 2R by R multiplied by minus VR by 4. So if you simplify this, you will be getting VR by 2, that is equal to VFS full scale voltage divided by 2. Thank you.